This is the title of the problem. I am using scikit-learn's Gaussian process regression GPR, a powerful machine learning technique, and I am adding a special type of kernel, called a constant kernel, to improve the model. I am trying to figure out how a constant kernel works in GPR. Specifically within scikit-learn. This is the core question of the quiz. I am given a multiple choice question where I have to select all the correct statements about a constant kernel. This section describes the context. I am working with the Gaussian process regressor from a scikit-learn library, which is a common tool for this technique. I suspect there's a constant offset, or bias, in the data I am modeling. This statement says the constant kernel adds a constant value, a fixed number, to the covariance function. This is true. It changes the model's overall prediction mean. This statement says that the constant kernel's parameter, constant value, must be positive. This is false. I can use any real number positive, negative, or 0. This statement says the constant kernel is helpful for datasets with a non-zero average value mean. This is true. Adding it will help the model to fit the data better. This statement says that using the constant kernel significantly slows down the GPR calculations. This is false. The increase in computation time is minimal. Here's the strategy. I need to carefully analyze each statement and use my knowledge of constant kernels in scikit-learn GPR. The first step is to check each statement against the function of constant kernels. I'll consider its impact on the computation time as well. I see that this statement highlights a key feature of the constant kernel. It doesn't just affect the covariance, how similar data points are, but it also directly impacts the average prediction of your Gaussian process model. Adding a constant value shifts the entire prediction curve up or down. This simply means that the constant kernel adds a fixed number to the output of your Gaussian process. This constant value is what allows you to model that constant offset or bias I mentioned earlier. The covariance function describes the relationship between data points. The constant kernel changes this relationship by adding a constant value. It's like adding a baseline level of similarity to every pair of points. This impacts how the model estimates values. This is the core topic using Gaussian process regression, a powerful machine learning method in specifically focusing on the constant kernel, a component that lets you model a consistent added value. Adding any kernel to a Gaussian process adds a little bit to the calculation time. But the constant kernel is pretty lightweight. It doesn't slow down the process much at all. The constant kernel's primary function is to add a fixed value to the covariance function. This added value influences the overall predictions of the model. It introduces a global adjustment, like a systematic error or bias. This is the name of the tool we're discussing. It's a special type of kernel function used in Gaussian process regression to handle a global bias or offset in data. It's a simple yet powerful addition. Think of it this way: if your data consistently sits above or below 0, the constant kernel helps your model account for that baseline shift. It is especially handy when you have data that doesn't center around 0. Google style NAMI emphasis. That's incorrect. Google style. The constant value can actually be any number, positive, negative, or 0. It's the magnitude and sign of that constant that dictates the shift in your Gaussian process models. Predictions. I am asking you to identify which statements correctly describe the constant kernel, a component of scikit-learn's Gaussian process regression. It's a multiple choice question testing your understanding of this kernel's function within a Gaussian process framework. This statement is correct. The constant kernel directly adds a constant value to the covariance function. This constant shift influences the overall mean prediction of the Gaussian process model, acting like a global bias or offset. This is incorrect. The constant value parameter can actually be any real number, positive, negative, or zero. It's not restricted to positive values only. This statement is also correct when data shows a non-zero mean. Including the constant kernel helps the model more accurately capture that average trend or offset in the data. This is false. While adding any kernel increases computation slightly, the constant kernel's impact is minimal compared to other, more complex kernels. It doesn't dramatically increase the overall computational cost. Google style name lively. It's computationally inexpensive. Google style. I am asking you to determine which statements accurately describe the constant kernel in scikit-learn, a tool we use in Gaussian process regression. Break time 300 milliseconds. Well, explore each statement carefully. Let's say you are using Gaussian process regression, and you think your data has a hidden constant offset that affects your predictions. The constant kernel is designed to deal with this problem. Gaussian process is a powerful statistical model for regression. Break time 200 milliseconds. I think of it as a flexible way to predict continuous values based on a set of data points. Break time 200 milliseconds. We model these data points as a Gaussian distribution. This refers to combining different kernels, such as the constant kernel, to create more complex models. Break time 200 milliseconds. Combining kernels allows us to capture more complex patterns. Think of it like assembling Lego bricks to build a more elaborate structure. Google style name lively. It's like building a more powerful model with a custom kernel. Google style. This is the core concept we're focusing on. Well, improve the accuracy of our Gaussian process regression by incorporating the constant kernel. Break time 200 milliseconds. Think of it as adding a fundamental piece to a puzzle. By applying the constant kernel correctly, we expect to obtain a more accurate Gaussian process regression model. The model will account for the constant offset, improving overall predictive accuracy. I see the term constant kernel here. It's a tool in scikit-learn, a popular Python library for machine learning. Specifically, it's part of the Gaussian process regression tools. Think of it as a way to add a fixed, constant value to your model's predictions, like a baseline offset. This helps model data that doesn't naturally start at zero. Break time 300 milliseconds. The covariance function, often called a kernel, measures how much different data points relate to each other. Adding a constant shifts the entire relationship up or down, making predictions systematically higher or lower. Think of it like adding a constant value to the average prediction. Break time 300 milliseconds. This question tests your understanding of the constant kernel in scikit-learn's Gaussian process regression. Break time 300 ms. You need to assess which statements accurately describe how the constant kernel functions and affects the model. Break time 300 milliseconds. This statement is correct. The constant kernel does exactly that. It adds a constant number to the covariance function of the Gaussian process, which in turn introduces a global bias or constant offset to your predictions. Break time 300 milliseconds. This statement is also correct. If your data consistently has a non-zero mean, meaning that the average value is not around zero, the constant kernel can help to improve your model's accuracy by adding a baseline offset to account for this non-zero average. Break time 300 milliseconds. This is incorrect. The constant value can be any real number, positive, negative, or zero. It doesn't have to be positive. Break time 300 milliseconds. This is false. While adding any kernel adds some computational cost. The constant kernel is computationally inexpensive compared to other, more complex kernels. It doesn't significantly slow down the calculations. Break time 300 milliseconds. This quiz tests your understanding of the constant kernel in scikit-learn's Gaussian process regressor. I'll guide you through it. Break time 300 milliseconds. This is the core question. I want you to select the correct statements about the constant kernel based on your understanding. Break time 300 milliseconds. This statement is correct. The constant kernel directly adds a constant to the covariance function. This constant influences the overall mean prediction of the model. Think of it as a baseline shift. Break time 300 milliseconds. This statement is false. The constant value parameter can be any real number, positive, negative, or 0. It represents a constant offset and can be adjusted accordingly. Break time 300 milliseconds. This statement is true. If your data has a consistent mean, it's not centered around 0. The constant kernel helps you capture that non-zero mean effectively in the model. Break time 300 milliseconds. This statement is false. While adding any kernel increases computation slightly, the constant kernel's impact is minimal compared to other, more complex kernels. The increase in computational cost is negligible. Break time 300 milliseconds. These are the multiple choice answers to the quiz question, requiring you to assess each statement individually. Break time 300 milliseconds. This phrase summarizes the core topic using Gaussian process regression, a powerful statistical modeling technique, with the specialized constant kernel. Break time 300 milliseconds. Gaussian process is a sophisticated method for modeling functions, incorporating uncertainty estimations. It's like having a well-informed guess about the behavior of a function. Break time 300 milliseconds. The constant kernel is a specific kernel function used within the Gaussian process framework. It models a constant offset or bias in the data. Break time 300 milliseconds. The covariance function, or kernel, describes the relationship between data points. It tells how similar they are. The constant kernel adds a constant value to this function. Break time 300 milliseconds. The data you use to train the Gaussian process regression model with the constant kernel. This is your input. Break time 300 milliseconds. I see constant kernel here. It's a component we use in Gaussian process regression. Think of it like adding a constant background hum to your model. It helps account for any consistent offset or bias in your data. This phrase explains what the constant kernel does. It takes the covariance, a measure of how much data points relate, and adds a constant value to it. This impacts the overall prediction of the model, particularly affecting the average prediction. This is the core question. You are being tested on your knowledge of this scikit-learn tool used for Gaussian process regression, a statistical modeling method. This tells us the context of the question. We're dealing with a Gaussian process regression model that's using a constant kernel to enhance the model accuracy, specifically for datasets with a constant offset in the dependent variable. This statement is false. The constant value parameter can be any real number, not just positive numbers. It can be positive, negative, or 0. Representing a constant offset. Break time 300 milliseconds. Think of it like adjusting the baseline. It could shift the results up, down, or not at all. This is also false. While adding any kernel adds some computational cost, the constant kernel is computationally inexpensive compared to other, more complex kernels. It doesn't significantly slow down the process. This is true. If your data's average value isn't 0, the constant kernel helps your model better capture that non-zero average. This is true. The constant kernel fundamentally adds a constant value to the covariance function that's its main job, resulting in a consistent global adjustment to the predictions. This is a key feature. The question focuses on understanding the properties and effects of using a constant kernel within a Gaussian process regression model. You need to analyze how the constant kernel influences the model's predictions and computational aspects. I am using Gaussian process regression, a powerful statistical model, and adding a constant kernel to it. Think of it like adding a baseline level to my predictions. This question tests your understanding of how the constant kernel works in the Sklearn library, a popular Python machine learning tool. We're focusing specifically on this special type of kernel. This statement is false. The constant value parameter, which is part of the constant kernel, can be any number, positive, negative, or even 0. It doesn't have to be only positive. This is also incorrect. While adding any kernel adds some computational cost, the constant kernel is computationally very efficient. Its impact on computation time is negligible compared to other, more complex kernels. Google-style name enthusiastic. It's like adding a tiny grain of sand to a beach. You won't even notice the difference. Google-style. This is true. If my data has an average value that's not 0, the constant kernel helps my model account for that. It's very handy for incorporating a non-zero mean value into my model. This is also correct. The constant kernel's main job is to add a constant value to my covariance function. This changes how similar data points are seen by the model, effectively shifting the entire prediction slightly up or down. Statements A and C are the ones that correctly describe the constant kernel in Sklearn. Statements B and D are false and should not be selected.